equation kx squared plus x is equal to 50. Kx squared plus x minus 15 equal 10 has roots a, alpha, and beta. Determine the expression for alpha plus beta. Remember, though, that the sum of the roots, of which we call it alpha plus beta, is equal to minus b over a. We can find that by using the formula minus b over a. Let me write that a little better. Somehow that looks a little bit disgusting. So this is minus b over a. And the product, which is alpha times beta, is equal to c over a. So what we're going to do is to take that and represent it, because you notice this says write expressions for it. So then let us say we're taking a kx squared plus x minus 15 equal to 0. So from this, a is equal to k, b is 1, and c here, we have to work out c here, because all of this is equal to 10, should say 10 here. So to get this on this side, we're going to have to add, and going to have to subtract 10 from both sides, as you could see here. So we subtract 10 there, subtract 10 here. So technically what we have here is a kx squared plus x minus 25 equals 0. So c is equal to negative 25, right? With that said, we can simply take these. K, a is equal to k, b is equal to 1, c is equal to negative 25, and then represent it. So let us look at this. We want to write the expression for the sum, which is alpha plus beta. As we said, it is actually minus b over a. And in this context, minus b is going to be minus 1 over a, and a is actually k. The sum is minus 1 over k, but the product is going to equal to c, which is negative 25 over a, and a is called k. So these are the solutions that we're looking for. For the sum, we have a minus 1 over k, and for the product, we have 25, negative 25 over k, and we're good to go right there. All right. Now let's take a look at what else they want. So as we go further in the question, it says here, given that a alpha squared plus beta squared is equal to 61 over 4, use the expression above, which is these that we just have here, to determine the value of k. All right. Remember though, this, we need to remember the identity for this. So I'm just going to jump into it. So alpha, guys, my screen is jumping. All right, let me put it there. So alpha square plus beta square can be represented as the sum, which is alpha plus beta, all square, right? Minus 2 times the product, which is alpha beta. So this is actually an identity that we can use to represent for this. So with that said, we can take this idea, and when I say this idea, I'm referring to take this, which is alpha plus beta square minus 2 times alpha beta, let that equal to 61 over 4, because it is 61 over 4. So let us do our quick substitution. What is the sum? The sum was minus 1 over k. So we're supposed to square that, because remember, that was the, when we work out the sum, it was negative 1 over k. So we're going to square that, minus 2 times the product. And the product was actually, if I put it in a bracket, it was actually negative 25 over k, right? So negative 25 over k, take a look at them. Here is the sum, and that's the product right there. Now, let's keep moving. This is equal to 61 over 4. Let us work these out. Whenever you square anything, it is positive, so this becomes 1 over k. And this part, though, becomes positive 50 over k. This is equal to 61 over 4, right? This is k squared, my bad. So let us multiply throughout, right? Let us multiply throughout by 4k, 4k square in terms of so that we could cancel. For example, we're going to multiply this by 4k square plus 4k square times the 50 over k. And that is going to equal to 4k square times the 61 over 4. So basically what I'm doing is I'm multiplying throughout by 4k square in an effort to do canceling where necessary. So let us see if we can do some canceling now. The k square cancel right there. The k cancel, k square leaving that this k, and then the 4 cancel 4 here. And let me rewrite what I have. So after we cancel, what we really have now is 4 times 1, and this is going to be 4. So we have a 4k times 50. That's going to give me 200k. And this is going to equal to 61k squared. Let us subtract 4 and 2 and subtract 200k from the left side, which means that on this side, we're going to have subtract 200k minus 4. Remember, though, that all of this is going to now equal to 0. So basically, this is what we really have. We have 61k squared minus 200k minus 4, and this is equal to 0. So this gotta be factorized. So we're gonna have to solve this. So A is gonna equal to 61, B is equal to negative 200, and C is definitely negative 4. In an effort to find K, we're saying that K is gonna equal to the opposite of B, so it's gonna be positive. So it's gonna be positive 200 plus or minus the square root of b squared, which is 200 squared minus 4 times a is 61 times c is negative 4. All of this definitely must be over 2 times a is 61. Let us keep going. So this is going to be 200 plus or minus the square root of 200. This is going to give me 40,000, definitely. Let me work out the other one. That's negative 4 times 61 times negative 4. We're going to get about 976. All of this will be over 2 times 61. That's 122. Let's keep going. This is still 200 plus or minus. So this is the square root of 40,976 over 122. So let's find that 40,976, the square root of that. I'm getting some 202. All right, so basically this is what I have. I'm getting 202.4. Right? All of this will be over 122. At this time, we can just finalize the idea because k is equal to all of this. So here are the solutions. We're saying that k is equal to 200 plus 200 plus 202.4 over 2. That's one of the answer, which is going to give us 400 and over 122, my bad. So this is going to give us 400.402. Hold on, let me write this properly. All right, so we're talking about 402.4 over 122. All right, so let's work on 402.4 divided by 122. We're going to get a 3 point. So this is giving me 3.3. So that's one value for k. Also, we're saying that k is equal to 200 minus 202.4 all over 122. Let's do that. 200 minus 202.4. That's giving me, so definitely I'm getting negative 2.4 over. If we divide this by 122, we're done. So I'm getting k is equal to negative 0.019. I'm just going to say 0.0196. That's what I'm getting right there. The question says here, it says, for the quadratic function g of x is equal to negative 5x squared minus 4x plus 2, determine the exact value. Determine the exact value of the, okay, exact value of the maximum point and the range. Okay, when they say the exact value here, um, they don't want you to round it off, right? Because you may end up getting some fractions. So instead of round it off the decimal place, you're not going to round off your answer. You're going to keep it as a fraction. And that is why they really say exact here, because they did not want a rounded figure. So you want to keep it as fractions, because fraction is exact. But when you round off, not really. All right. There are many ways you can do this. So I'm going to do it one way. I know that you do it a lot of ways. I'm just going to do it one way. Let us go through this. What we have here is negative 5x squared minus 4x plus 2. I'm going to divide throughout by negative 5 because I want I want my square. I want the coefficient of the square to be a 1. So what I really have now is x squared, and this becomes positive 4 over 5x. This becomes negative 2/5 right here. So basically how we do this here is that I'm going to represent this x squared plus 4 over 5x. I'm going to leave a space to put a number here. So I'm going to complete the square here. And then this is negative 2/5. And I'm going to subtract whatever number I put there here. It's a half of b. This is 4 over 5. Half of it is 2 over 5. And I'm going to square it. But it's going to be a plus here. So I'm going to have to take it back here. So it's going to be a 2 over 5 square here. So basically, if I should just write this so that we could look at it, this is x squared plus 4 over 5x plus 4 over 25 right here. This actually becomes, if I should take this to the side, so this is like negative 2/5 minus 4 over 25. But if I want to work with the same denominator, I could multiply everything by 5 over 5. So I could multiply this by 5 and this by 5. So my denominator becomes 25. So this is like negative 10 over 25 minus 14 over 25. So as equal to minus 4 over 25. So we end up with minus 14 over 25 right here, which means that this is what comes here. At the end of the day, let us factorize this. This is a perfect square, so it's going to be x plus 2 over 5 all squared, and this is minus 14 over 25. To anchor the idea, remember that we divided in the early by negative 5, so we're going to have to multiply the two terms by negative 5. So when you do so, right, you could see negative 5 into this cancel, right? So this is going to be 5. This is negative 1. So what we're looking at here is when we do this, what I'm going to have here is this. So this is it now. Negative 5, open bracket, x plus 2/5. This is going to be squared. And then this is going to be positive 14 over 20 over 5. 14 over 5, all right? So it's going to be 14 over 5 because the negative and the negative, so this becomes 14. So let me highlight the response. So this is the answer right here. Well, this is what we're going to use to get our answers. So now in a response to the question, they want us to determine the exact value of the maximum point. So we're not going to round it off. So the maximum point is going to be, so max point here, as you could know, it's going to be that x value here, right here, which is going to be the opposite to it. So it's going to be negative 2/5, right? So negative 2/5 and 14 over 5, right? Because remember though that uh the maximum point, this is not this is not it. It's the opposite of this that will give us that. So it is actually negative 2/5 point, negative 2/5, 14 over 5. All right. What do they have? So for the range now, so g of x will be so this has a maximum point. How you know? Because your a value was a negative 5, so the curve turned like this. So what we're talking about is that this this coordinates that we have for a vertex here, the negative 2 over 5x, and then the 14 right here, right? All of that we have right there, we're saying is that this is our maximum value. So it's going to be less than or equal to that number right there. So the range is going to be that g of x will be less than or equal to 14 over 5.